Hello, students. I really want to talk to you today about solving word problems and particularly about avoiding shortcuts. I've noticed in the discussion for this week, there are several students that have been using shortcuts to try and solve word problems. And the biggest problem with this is that the shortcut might work for one type of problem, but we're going to look at more complicated types of problems later where the shortcut doesn't work. And if you don't get practice with the step-by-step method for solving word problems, where we make let statements, we write an equation that models the situation, we solve the equation, etc., you're going to find that you're not prepared for the more difficult problems that we do later on. So what I want to do is I want to give an example of a shortcut that some students are using, and I want to show you some of the other sorts of word problems we're going to be looking at later where that shortcut is not going to work, to try and motivate you to not rely on these shortcuts. So let's look at an example to start with of a shortcut. In a certain city, a taxi ride costs a flat rate of $2.50 plus an additional $1.25 per mile traveled. How far did Elena ride if she took a taxi and was charged a total of $33.75? So the way that I have been encouraging students to solve these sorts of problems, and the way that I expect students to solve these sorts of problems, is by starting off with let statements and then writing an equation that models the situation. So we're asked, how far did Elena ride? So that's going to be our variable x. Let the distance Elena rode be x. And that's Elena with an E, not Elena with an A. Not that it's a real Elena, so it doesn't matter. So that's the only thing that we're asked to find. So that's going to be our only let statement. Now we need to write an equation that models the situation. And so we're looking at the total cost of the ride as $33.75. So we know that the way that the meter charges is that there's a flat rate of $2.50. So just stepping into that taxi, Elena is charged $2.50, but then also plus an additional $1.25 per mile. Now you can see the word per there. That is a rate. Since it's $1.25 per mile, we need to multiply 1.25 times the number of miles that Elena travels, and that distance is given by x. So we have to multiply 1.25 times x, and then the total cost is $33.75. Now we have an equation that we can solve to figure out what x is and get the conclusion to this word problem. So to solve this, we need to subtract 250 from both sides of the equation. This gives us 1.25x equals, 3125. And then to get x alone on both sides, we need to divide by 1.25. And 31.25 divided by 1.25 is 25. So we get x equals 25, and this is measured in miles. And so we're asked, how far did Elena ride? And we can say Elena rode 25 miles. That is how we solve a problem like this. Now, there are some students I've noticed in the discussions who are using a particular shortcut. These students have decided that they don't want to write out let statements, they don't want to use variables and equations, they want to just use their knowledge of the situation to figure out what's going on. And so these students are saying, well, it was $33.75, and there was that flat rate of $2.50. So we're going to get rid of the $2.50 by subtracting it. So 33.75 divided by $2.50, and that gives $31.50. That's the amount that went towards the per mile rate. And then it's $1.25 per mile. So students are taking this 3150 and then dividing it by 1.25 and getting 25. And there are a lot of students that are doing this and saying this is a lot easier than the other method. We don't have to write out let statements. We don't have to set up variables and equations. We can just figure out what the answer is to the problem. And it is absolutely true that some of you can use this method to solve the problem, and it is less work than the other method that I've done. But this shortcut does not work in all of the types of problems. For example, it doesn't work for problems about perimeters. We have this other problem. The length of a rectangle is 3 centimeters more than twice its width. If the perimeter of the rectangle is 72 centimeters, find its length and width. We can't just take 72 minus 3 and divide by something like we did in the other problem. The math that's happening in this second problem is more complicated, and so we really need to be making let statements, setting up an equation that models the situation and solving it. We just simply cannot use this same shortcut. And then there's going to be other types of problems in the future where we also cannot use this shortcut. Here is an example of what's called a uniform motion problem. An airplane can fly 900 miles in 3 hours when it's traveling with the wind. However, the return trip against the wind takes 5 hours. Find the speed of the plane in still air and the speed of the wind. This is an even more complicated situation that we cannot solve without let statements and variables and writing equations and solving equations and things like that. And here is another type of problem. This is a shared work problem. It's a problem that you will see in Math 60. And this is another one where we just cannot use shortcuts. We absolutely need to define our variables, write let statements, set up equations that model the situation, and use that method to solve these problems. And so I personally want to discourage you from using these shortcuts, because what happens, and I've seen this in the past, is that students who use the shortcuts on simple problems don't end up learning the step-by-step method that I've been teaching with let statements and equations and variables and all that. They don't really learn that method. And then what happens is when they get to these other types of problems, especially the more complicated ones that you cannot use shortcuts on, the students don't understand the process and they struggle very, very much with these problems. They don't know what their let statements should be. They don't know what the equation's going to be because they never got practice on the easier problems. Really, I know for this first problem, you all can probably go through and use this shortcut. The reason I'm making you go through and learn this problem-solving process is because we're going to need it later on. And if you don't learn the problem-solving process for the easier problems where it's not that complicated, and you wait until we get to the harder problems and you have to fall back on it, you won't understand it. You'll feel that it's too complicated and you'll feel like you're drowning because the problems are just too complicated. So this is, I'm sorry it's a long explanation that I've just given, but it's an explanation of why it's really important for me that everyone understands how to write let statements, how to set up an equation that models a situation, how to solve, etc., because those are skills we're really going to need later on. And one last thing, this whole process of setting up variables to represent different quantities and making equations, this is exactly how computer programming works. If you learn programming languages, if you want to design video games someday or work as a programmer, anything like that, you will need to write code where you are defining variables and you're using functions and other relationships between these variables to make different things happen. And so this sort of thinking, where we're translating English sentences and real world situations into variables, expressions, and equations, is exactly what happens in computer programming. So that's another reason why it's really important for me that we're getting these skills. So if you have listened to this whole 10-minute video, thank you for your attention. I really appreciate it. I really hope that this makes sense. I'm not trying to be to be a really mean person and make you learn a method that you'll never need, because the shortcut's fine. It's really important that you learn this method so that you're really comfortable with some of the harder problems we'll be looking at throughout the course of the semester and throughout some of your future math classes.